Hello students, today we are going to be going over 11.5a, recursive formula for geometric sequences. Now, this is going to be page 164 for honors, I believe, and 153 for regular SM1 classes. So you should know what page that's on. I can check down here again, 164 for honors, and then 153 or 152 for regular. Okay, all right, so we're going to go over recursive formula for geometric sequences. We have already gone over recursive formula for arithmetic sequences, and now we're going to go do the same thing for geometric sequences. And your objective is I can use and write recursive formulas for geometric sequences. A recursive formula is written with two parts. The first part is a statement of the starting term, A1, or it could be f of 1 if it's in formula notation, function notation. The second part is a statement of the formula relating to the successive terms. This is written as an expression containing the previous term a to the n minus 1, or it would be f of parentheses n minus 1 if it was function notation. So we're given a geometric sequence here. Okay, here's the function notation, and here's the sequence notation, and here's the term number. So the first term is 3, second term is 6, third term is 12, and so forth through all of this. As you can see over here, it is graphed. Now, they didn't connect the points, but if they did, what type of graph would that be? And you're correct. That is going to be an exponential graph, which we just went over previously. Here's the process of writing a recursive formula for a geometric sequence. You always state the first term. A1 is the first term, or f of 1 is the first term, which in this case is going to be 3. Here it says determine if the sequence is geometric. So we want to take the second term and divide it by the first and see what you get. Third term divided by the second, fourth term by the third, and fifth term by the fourth. So if you do all that and you get the same number and you realize, oh, 3 times 2 is 6, 6 times 2 is 12, 12 times 2 is 24, 24 times 2 is 48. So we know that it is a geometric sequence. The common ratio we just found out was times by 2. Then we create a recursive formula stating the first term and then stating the formula to be the common ratio times the previous term. So over here again is some vocabulary where we say A1 is the first term, f of 1 is the first term. Over here, a to the n equals r, which is the common ratio, times the previous term, which is a to the n minus 1. So that's the same as saying f of n in function notation equals r, or the common ratio, times f of n minus 1, and that would be the previous term. So a1 equals the first term in the sequence, f of 1 equals the first term in the sequence. A to the n and f of n is the same, the nth term in the sequence. A to the n minus 1 equals the term before the nth term, and f of n minus 1 equals the term before the nth term as well. N is the same thing in both of them, the term number. R is the same thing in both of them, and that is the common ratio. So now we're going to write the recursive formula for all of that in both notations. We know that a to the 1 equals 3, as seen up here. A to the 1 is 3, and we know our common ratio is times by 2. So we get 3 is our A1. We always write what A1 is. Then we say our recursive formula is a to the n equals 2, because that's what it's multiplied by, and then it's the previous term. So there's your recursive formula. Here, f of 1 equals 3. It tells you where to start. And then your formula, f of n equals 2 times f of n minus 1, which means 2 times the previous term. That's why it's n minus 1. Okay, I will continue this on instructional video. Good luck, students. You rock.